So today we're going to be talking about the slope intercept form. And the slope intercept form is one of those key formulas or tools that we use throughout all of algebra. Anywhere in the world that you go, if you take an algebra course, you're going to be learning the slope intercept form. And as the name implies, the slope intercept form, the two main pieces of information that you're going to have with the slope intercept form is the slope and the y-intercept. And so the formula, a lot of us have heard y equals mx plus b before. Now, those pieces of information, the slope is going to be the m value. So we're talking about whatever number is in front of the x. And the y-intercept will be whatever number is added or subtracted over here at the end. So we're going to go through some examples and help identify the slope and the y-intercept when looking at the slope intercept formula. So like on this first example, the number that's in front of, the number that is in front of the x, so I can show, get a little bit of it there, a little bit of it in the frame. So the number that's in front of the x is the 3. So that is going to be our slope. Our slope in this case is 3. The y-intercept is the number that's been added or subtracted at the end here. So in this case, our y-intercept is a positive 4. Scrolling up, we can see in this particular example that the number in front of the x is 2/3. So our slope is 2/3. And our y-intercept is the number that's been added or subtracted to the x. And our y-intercept in this particular case is -5. Moving on, we have a little bit different version of different view of a problem here. Now, the number in front of the x, that's still going to be our slope. So in this case, our slope is a -4. But it's kind of difficult to identify what our y-intercept is. What I want you to do is I want you to think about this problem as if it was y equals -4x plus 0. We don't see a number out here, so the number would be 0. And so in this particular situation, kind of imagine that there's a 0 there and our y-intercept would be 0. Moving down to another example, this one, you see we don't have an x, and so there is no number in front of the x. And so we're going to kind of imagine that it looks like this, y equals 0x minus 2. So our slope is 0, and our y-intercept would be the number that is added or subtracted to the x at the end here, and that is going to be a -2. So I'd like to talk about one more example. What if you had an equation that was written like this? Y equals x, let's say plus 4. So we're going to ask ourselves, what is the slope and what is the y-intercept? So it's pretty easy to recognize that, hey, our y-intercept is this number that's been added or subtracted to the x value. So our y-intercept is going to be a 4. Now, getting back to the slope, I don't see a number in front of the x. And so we have to ask ourselves, what number is in front of that x right there? What I want you to do is I want you to think about it as y equals 1x plus 4. So our slope is going to be a 1. Okay. Now, in case that messes with you guys, I want you to think about it this way. I want you to say, how many x's do you see right there? Most students will say, oh, Mr. Buckles, I see 3 x's. Yep, that's true. How many x's do we have right there? But once again, students will say, Mr. Buckles, we have 2 x's. Then I say, okay, now students, how many x's do you see there? And they'll say, Mr. Buckles, I see 1 x. Okay? So anytime you have a letter in algebra that does not have a number, you don't see a number in front of it, you can automatically assume that there will be a 1 in front of that. One of the benefits of the slope intercept form and why it's so useful is when it comes to graphing. You've learned various ways to graph up to this point in your math classes. But if you have something written in slope intercept form, it is the easiest way that I know of to graph a line. And to do so, we're going to start with putting a dot on the y-intercept. Now the y-intercept is where the y-axis, our vertical axis right here, that is where the line that we're graphing is going to cross this y-axis. Okay? So we're going to go ahead and put a dot on the y-intercept, and in this particular case, our b value is -1. So we're going to put a dot on -1. The next step is that starting at our y-intercept, we're going to start counting out the slope or plotting the slope. In this particular case, the m value we have is 2/3. So our slope is 2/3. And if you remember back to your lessons on the slope, slope is going to be the rise over the run. So the top number means that we're going to go up 2, and the bottom number is our run, which means that we're going to go to the right 3 spaces. So starting at this dot, we're going to go up 2 over 3, up 2 over 3, up 2 over 3, and this pattern can go ahead and continue. And the pattern can work in reverse as well. So we can go back 3, down 2, back 3, down 2, back 3, down 2. And then that's basically the line. Then we just have to go ahead and connect the dots. Let's make it that way. All right, so now we have our line that we've graphed. And this line is the same thing, it's just a graphical representation of the equation y equals 2/3 x minus 1. What I like to think about is, I like to think about this equation is basically the address of this line. There is no other line that we can put on this graph that will have this equation. This equation is specifically connected to this line. Let's go and take a look at another example of how to graph using the slope intercept form. So now we're going to go ahead and graph this next equation, y equals -3x plus 2. And once again, we're going to start by putting a dot on the y-intercept. And in this particular case, our y-intercept is at +2. So that we know that the line that we're graphing is going to cross our y-axis, this y-axis right here. It's going to cross it at +2. So we start by putting a dot on +2. And then we're going to plot our slope. Now, in this particular case, our slope is a -3. So if you think back to your studies on the slope formula and what slope is basically a fraction, and it's going to be the rise over the run, okay? So if we take -3 and we write it as a fraction, we'll have a -3 over a +1. So this means that starting at this point right here, we're going to go down 3 and right 1. So it's a -3 over a +1. So we can go down 3, 1, 2, 3, +1, down 1, 2, 3, +1, down 3 over 1, And we can work in reverse as well. We can go up 3 and back 1, up 3 and back 1. Okay? And then, once again, we can go ahead and connect these dots. Okay? And this line that we've graphed now, this line is the line that is represented by the equation y equals negative 3x plus 2.